Today I wanted to talk a little bit about a topic which I kind of needed to delve into, for both because I wanted to and because I needed to, because of a possible job situation. But first I wanted to mention that it's very important for you to know that I'm brand new to this topic. And actually I have almost never seen these kind of documents before in my work. But these documents are a little bit similar to some diagrams which we call P&IDs, which are among other places used in the North Sea in the oil and gas business. And these diagrams, they are a little bit similar to those P&IDs. But the P&IDs are kind of they are more useful for getting information about details about certain equipment. Let's say you take a kind of a pump, and on a P&ID, this pump will be shown with all kinds of extra pipes and valves which are needed to, let's say, when you want to start a pump, you want to get rid of air inside the pump before you start it. And the P&IDs, they show all the small valves, all the pipes, everything which is kind of important to know about. Let's say if you are a worker outside and you want to start a pump, and also for doing maintenance. But the thing I wanted to talk about today is some drawings which are called SCDs, which is a shortcut for System Control Diagram. These drawings, they do have some of the information like the P&IDs, but they have a lot less of let's say, they show very little about details about the pump. They show more or less how you control the pump and all the functions which are connected to the pump, like from a control system. So these drawings are primarily used for getting to know how the whole system is controlled and everything which affects it control-wise. So that's kind of the best way I can describe it. As I said, this is the bare beginnings for me to understand these drawings, but I will just take it as it goes, and maybe some of you have some comments about it, and definitely there will be a lot of things which I may explain wrong, and it's no problem to comment on that. So let's start looking at this topic. Okay, so here is a sample of SCD drawing. The building blocks in these kind of drawings are based on a document which is called NORSOK I-005, which is a standard, Norwegian standard. And this document describes in very detail how to build these components in these diagrams. That document is very extensive, and it's also a document which has to be bought, and it's obviously copyrighted, so I can't really show the contents of that document in this video. But many of the blocks here, like this one is a block, this one is a block, all those squares here, they are, we call them a block, logic block. And the different, let me zoom a little bit here. Like here, you see there are different descriptions here. And all those things here except that one, that is an ordinary tag, which is a name of the component, that component. And but there are many different types of codes here, call them codes, function codes. And they are to describe how the block works, or different kind of properties it has. You need to use that NORSOK I-005, which contains a lot of tables with a lot of codes and different things, and you have to combine those codes to describe what a block does and all its properties. Yeah, I can take like an example here, like the MA there. It stands for that this is like a measuring block. The main function of it is like measuring something, and the A is like describes that it's an analog block. Just like it's just a sample, you know. This document contains a lot of, as you see, yellow squares. And inside those squares I have written my own comments of what's going on at that point where they are located, which we can look at later. But as you see here, if you take like this pump here, if you found this pump like on a P&ID, you will see a lot of valves and pipes around this symbol here. But on these drawings here, those things are not important, so they are left out. Yeah. So that's a basic look at these kind of drawings. So what we can do first is to for me to try and explain like the function of the whole system here in short. The system here is like only a part of many systems on let's say an oil installation, and this particular system here is a system which treats a cooling medium. There are many parts of the installation which needs cooling, and this system here is kind of part of that. So what this system does in principle is that from all the systems which needs cooling, there is a return of that cooling medium from those systems, and the temperature of that cooling medium will be quite a lot higher than the temperature on the medium when it entered those systems. So when that cooling medium comes from those systems with a higher temperature, that cooling medium is like entering here. And what's going on is that the cooling medium is coming from this side here, and then it's going through some pumps, and those pumps deliver the cooling medium to some heat exchangers, those three here. So the function of those heat exchangers is to cool down the cooling medium coming from here, so that the temperature of the cooling medium here is at the proper temperature before it's delivered to a distribution for all those systems which needs it. What those heat exchangers here, they use seawater, which have a low temperature. They use the seawater as a medium for drawing heat from that cooling medium which comes here. So the seawater is entering here and draws heat from this cooling medium coming here, and so the temperature of the seawater is higher going here, and it's just transferred to seawater dump cation, which is just it's often just overboard on the installation. And the main medium which is in the system is the cooling medium, and it's going through here, lower temperature here, and goes out there to the different systems. Looking at the whole arrangement here, it's like it consists of like a seawater loop and a cooling medium loop. And one of the differences between them are that the seawater loop is kind of an open loop system, because the seawater goes through the system and is just dumped overboard. While the cooling medium loop is more like a closed loop system. Cooling medium goes through this and through the systems downstream, and then it comes back in here. So without some kind of expansion system, it's not really a good working system. So to counter that, it's you have this system here, this vessel here with the instruments around it, and the line going from that vessel down here. The vessel is partly filled with cooling medium, and on top of the liquid there is like a pressurized atmosphere of nitrogen, which comes in here. This vessel here, it works like a expansion tank for the cooling medium's loop. So liquid can go freely kind of both ways from this tank to supply the line here, or if too much pressure here, some of the liquid will be pushed up back in the tank here. And you can like adjust the pressure on the nitrogen atmosphere to set some kind of a suitable pressure for the line here, suction side of the pump. Also the vessel is like functioning like a pulsation damper in a way. It will, like, if you get pressure variations here, those will be kind of sucked up in the system here. If you get too much pressure here, there is something sensing the pressure and drops the excessive pressure out here to atmosphere. There is some more important things here. It's this valve here, valve system here, which we call like minimum flow valve. And what it does is that it returns excessive fluid on this line here back to the return side. And yeah. One thing to mention here, as you see, each pump arrangement is exactly the same, and why there are 3 pumps is that the system is a so-called 3 times 50% system. So it's often meant to be run with like 2 pumps at the same time to get 100% capacity. So we always have a 3rd pump like as a backup in case you get problems with one of the other pumps. Yeah. So, but the functions on each line is more or less the same. Same goes for this part here. It's exactly the same functions on each line here. One of the important things to the system is to try and keep the temperature of the cooling medium at a certain level. To achieve that, the system has like a sensor here measuring the temperature of the cooling medium, and based on that, if it's lower, you will need to close this valve here with the seawater to increase the temperature as much as you need on the cooling medium. Same goes if the temperature is too high here. Use this valve here to open it more, to give more flow of seawater through this to cool the whole thing here, so you'll get a lower temperature here. So what we talked about now is that we have the possibility to adjust the temperature of the cooling medium going out here using these 3 lines here. But there are other things which are important. One of them is to be able to control the amount of cooling medium going out to those different systems. So to try and explain that, I think we can look at these pumps here first. These pumps here are like something called centrifugal pumps, and as I have understood this in this system here, these pumps here are not, it's not possible to control the speed of these pumps to adjust the amount of fluid going here. So I will consider that these pumps here, when they are started, they deliver a certain full speed and will deliver a certain amount of fluid, no matter what. So that's how they work. Let's say if the pipe here was an open pipe, and or it had a certain restriction here, the amount of fluid going through this outlet here would be more or less constant. So using the pumps we can't control the amount of fluid going out to those different systems. So therefore we need quite a lot of equipment to be able to keep control of that part there. The main thing which actually controls the amount of fluid going out here is this valve down here in the corner here. It's a flow valve, control valve here. So what this control valve does is that it's the fluid coming to this control valve here is taken out from this line here. So what you can do to increase or decrease this flow here is that you let more or less fluid back again to the inlet system. So this valve here is like the main thing which controls the amount of fluid going out here. So to be able to measure the pressure, flow and temperature of the system, we need some equipment installed here. First look at this pump here. The pump here is like designed so that it can handle a very high pressure on the outlet here. Actually, if you close the line totally here and it's running, it won't hurt the pump. That's the way of the way they work, these centrifugal pumps. So you don't really primarily need a protection to watch out for a high pressure on this side here. But what you need to take care of first is to make sure that the pressure on the inlet of the pump doesn't get too low. So on the inlet here you have like a sensor which detects if you get a too low pressure on the line here. First it will warn about the pressure getting too low, and if it gets too low, it will shut down this the electrical part of this pump so that it will stop. On the outlet you have something which watch out for the flow. You need to make sure that you get a flow through the system. So you have this transmitter here, which measures the flow, and the function of this particular one is that it measures if the flow is getting a little bit too low, and then it warns about that. And if it gets too low, it will shut down the electrical part of this pump, so it will stop. That's like the basic principle of these transmitters here. You have the same arrangement on all the pumps to kind of detect problems around the pump. When it comes to the common line from the pumps, that's where you kind of sense how much the total flow from the system is, and you have kind of a like a regulator here, which basically controls this valve down here. But what this regulator does actually is that it senses like two different measurements. It senses the flow on the lines here, and it also senses the temperature of the line. And what it does is that it selects the highest value kind of the flow and the temperature. And if like the temperature is a little bit critical, it uses that signal to control the valve. And if the flow is problematic, it selects the signal from the flow measurement and uses that to control this valve. So with this brief explanation of how this system works process-wise, I think I will end this part. Part 2, I will probably look more into the SCD part, where we can talk about how the signals is designed in the system, control-wise, more in detail. Okay, bye-bye.